So we found the length of dt being 10 units. So with that piece in mind, now we want to find the length of xs. So again, let's think about what we said with our triangles. We know that we had the 4 individual triangles congruent to each other that we proved by side, 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 and also by hypotenuse leg, the individual pieces. So then what we want to do to find xs, right, that's here. And so xs corresponds to xt, and we want to see if we can link those together, right? So here's the right triangle that we're looking at. We already know the similar pieces, and let's see if we can apply the same ideas to this triangle. So we're looking for this length here. Well, we know a couple of things. So we talked about in our last problem, we have a 30, 60, 90 right triangle. We know the patterns and the ratios that exist for those. And so if we look for xs, right, that's the side across from the 60-degree angle. And so if we know that short leg here across from the 30-degree angle, we could find this one by using our pattern. Well, we already solved for that piece, right, in the previous one for number 1, dt. We said that was 10 units. And so then if we know that length, we can just use that ratio that we know that exists for your 30, 60, 90s and find the length there. So we know that xs should have a length of 10 square roots of 3, which is approximately 17.3 if you were just using your calculator. We also know that we're not just confined to using our 30, 60, 90 pattern for that. We also could talk about the right triangle and that xs is adjacent to your angle of 30 degrees. So the adjacent and the hypotenuse, that would be your cosine function. And so we could use the cosine to solve for the length as well. So here we can see set for our cosine to undo that division, multiply, right? And that's how we're getting our answer. This for sure, if you're using your calculator, would give you the 17.3, which you know is equivalent to 10 square roots of 3. So continuing on with our lengths, we want to know the length from x to a. So again, x to a, that's from the center of the circle to the circumference that represents a radius. And we said all the radii are equal, so that would have to be 20 units in length. The next piece we want to look for is our length for AB. And we said in the beginning of our givens that AB is equivalent to DC. So again, the length for our chord AB, those are made up of 2 of our equivalent pieces of DP. So that would have to... So the length of our chord AB is made up of 2 equivalent pieces for a length of DT. So 10 and 10 would give us a length of 20 units. The next piece that we're looking for is a measurement for DC. So a couple of ways because of the printing on the worksheet. If it's just 2 capital letters, the measurement, it could be the length of the chord DC, which we can see are 2 of our equivalent pieces for DT. So 10 and 10 would be 20 units. Now if you interpret it as the measurement for the arc DC, right? We want to look at the measurements of the arcs. We know that the measurement of the arcs are related to the types of angles that intercept it. So here we have central angles because the vertices are all at the center of the circle extending out. And so let's see what angle could we use that would have this as the intercepted arc. Well, it has to go through D to the center of the circle and C to the center of the circle. So we have a central angle here. Of DXC. So let's see, what do we know about the measurement of this angle? It's made up of 2 of our angles from our triangles. So 30 degrees and 30 degrees is 60 degrees. So the measurement of the central angle is 60 degrees, therefore its intercepted arc DC would also be 60 degrees.